Ever feel like just overloaded?
Yeah.
Like you're drowning in information, articles, research, opinions coming at you a mile a minute.
Oh, yeah. I hear you. It's a lot to sift through these days.
It really is. Feels impossible to keep up sometimes.
Yeah.
But that's kind of why we do this whole deep dive thing, right?
Absolutely.
Cut through that noise and find the stuff that really matters.
Yeah.
So today we're diving into something that sounds super complex, but is actually really fascinating once you get your head around it.
It's one of those things that can seem kind of out there, but it really makes you think about the world in a whole new way.
Exactly. We're talking about the Computational Theory of Perceptions, or CTP,
CTP. Yeah.
and it all starts with this idea that computers, they think differently than we do, right?
Yeah. They see things in black and white, ones and zeros.
Totally.
Mhm.
But our human perceptions, they're way more nuanced, right?
Right, definitely. Think about it. Like, what does tall mean, really? Or hot?
Right. It's all relative. Depends who you ask.
Exactly. And CTP, it gets that. It uses something called fuzzy logic to represent that gray area in our thinking.
Fuzzy logic, okay. So instead of just tall or not tall,
Yeah.
you've got like,
Degrees of tallness. It's about recognizing that our perceptions aren't always so cut and dry.
and those perceptions, they're built on even smaller building blocks, right? These things called granules.
Granules, yeah. Like, think about comfortable weather. What does that even mean?
Right, totally subjective.
Exactly. For you, it might be 70 degrees and sunny. For me, I might need it a bit cooler, maybe a light breeze.
So everyone's got their own definition built from these little granules of information. That's so cool.
And that's what makes CTP so powerful. It gives computers a way to understand those individual differences.
Okay, so how does it actually work? Like, how does a computer actually use these fuzzy concepts and granules?
Well, it uses a special language called Generalized Constraint Language, or GCL.
GCL, got it.
And basically, it takes those fuzzy ideas, breaks them down, and turns them into a set of constraints that a computer can actually work with.
So it's like translating our messy human thinking into something a computer can actually understand.
Exactly. It's like teaching computers to think a little bit more like us.
That's wild. Okay, so give me a real-world example. How would this CTT thing actually play out, say, with something like a fitness tracker?
Okay, so imagine your fitness tracker is gathering all this data, right? Your heart rate, your sleep patterns, maybe even your stress levels based on your skin conductivity.
Okay, getting all that data, yeah.
Now, a traditional fitness tracker might just show you those raw numbers, which, let's be honest, can be kind of overwhelming.
Totally, just a bunch of numbers.
Exactly. But with CTP, it can take all that data and translate it into something you can actually use. So instead of just seeing heart rate, 120 BPM, you might get a message that says,
Hey, looking a little stressed today. How about some deep breaths?
exactly. Or, you've been crushing your workouts this week. Keep it up.
That's amazing. It's like having a personal coach right there on your wrist, but even smarter because it actually understands you.
Right. And that's the beauty of CTP. It bridges that gap between cold, hard data and the way we humans actually experience the world.
It's like building a bridge between two totally different languages. So cool. So we've got our heads around this whole CTP thing, right? Computers understanding our fuzzy human perceptions.
Yeah, like they're starting to think a bit more like us.
But here's where it gets really wild, like mind-bending wild.
Buckle up.
What if? What if these computers aren't just mimicking us? What if they're creating entire realities where those perceptions are actually real?
It's a trip, right? That's the whole simulation hypothesis thing.
Simulation hypothesis. Okay, so we're talking Matrix, Inception.
Kind of, but instead of sci-fi, it's based on, like, real philosophical arguments. Nick Bostrom, he's the guy who really dug into this whole thing.
Okay, Nick Bostrom, I've heard the name. So what's his take?
So he starts with this idea that in the future, civilizations are going to have computing power beyond anything we can even imagine.
Like harnessing the energy of stars, building computers the size of planets.
Exactly. And with that kind of power, they could create these incredibly detailed simulations of, well, anything, really.
Okay, so like super realistic video games.
Way beyond video games. Think like simulating entire universes with beings who have no idea they're in a simulation.
So they would think they're real, having real experiences, feeling real emotions. Wow.
Right. And why would they do this, you ask? Well, maybe it's for research, right? Like studying history with perfect accuracy. Or maybe it's just for kicks, like we build those elaborate model train sets.
So some super advanced civilization is out there building simulations of us, just to see what we're like.
It sounds crazy, but it's a possibility Bostrom takes seriously. And here's where it gets really freaky. He argues that if even a tiny fraction of these advanced civilizations decided to run simulations, there would be way more simulated universes than real ones.
Okay, so it's like if there are billions of these civilizations, even if only a few are running simulations,
You're going to have a lot of simulations. And statistically speaking, that
it's
means...
more likely we're in a simulation than not.
Exactly. It's a numbers game. It's like finding a four-leaf clover. If there are millions of clovers out there and only a tiny fraction have four leaves...
Chances are the one you found isn't unique.
Exactly. And Bostrom actually breaks it down into three possibilities. One, advanced civilizations like ours, they just don't last very long. Two, they do last, but they don't run simulations for whatever reason. Or three...
3. We're living in a simulation.
Bingo! It's wild, I know.
So where does all this leave us? We've talked about computers understanding us, maybe even simulating us. But what does it all actually mean?
Right. Like, is this a big so what situation?
Exactly. If I'm living in a simulation, does it, change anything about my life, my choices, my goals, even how I treat other people? Does any of it really matter?
That's the big question, isn't it? And there's no easy answer. On the one hand, if you really start thinking about it, you could say, well, maybe it doesn't matter as much as we think.
How do you mean?
Well, if our actions are all just like manipulations of code, maybe it's not so different from playing a video game, you know?
Okay, I see what you mean. Like, in a video game, the consequences aren't real, right? You can crash your car 1,000 times, no biggie, hit reset and start over.
Exactly. But here's the thing.
What if we don't know the rules of this game?
Exactly. We don't know the rules.
What if there are consequences, but we're just not seeing them? Like maybe our simulated actions have ripple effects in some grander code we can't even perceive.
It's like we're only seeing a tiny sliver of the whole picture.
Right. And that makes it really hard to know how to even think about things like free will.
Exactly. Free will, morality, all those big questions philosophers have been wrestling with for centuries, they get even more complex.
Because if someone or something programmed every decision we make, then how can we say we have any real agency?
It's a mind bender for sure.
It really is. But you know what keeps coming back to me? That idea of precision we talked about with CTP?
Right. Different levels of detail depending on what you're looking at.
Yeah, like maybe the architect of our simulation, if there is one, they focus their programming power on certain things. You know? Okay, I see where you're going with this. Go on. Like maybe they put all their effort into simulating consciousness, making our inner world super detailed and believable.
Making us feel real.
Exactly. But then maybe the physics of the universe, the stuff we can observe that don't experience directly. Maybe that's all just kind of approximated?
So like gravity glitches every now and then, or
Yes.
quantum mechanics is just a bunch of placeholder code.
Maybe. But if our emotions feel real, if our connections with each other feel real, how much does it really matter if they're the product of ones and zeros instead of, atoms and quarks?
It's a profound question, and for me, it really highlights that maybe the bigger point isn't about what our reality is made of, but what we experience within it.
Right. Our experiences, our relationships, even our struggles, they all still have meaning in the context of our lives. Whether it's real in some ultimate sense, maybe that's not the point.
It's a humbling thought, isn't it?
It really is. So maybe we'll never know for sure if we're living in a simulation. And honestly, after this conversation, I'm not even sure it matters as much as I thought it did.
I'm right there with you.
The real takeaway for me is that no matter what this reality is made of, whether it's lines of code or strands of DNA or something we haven't even imagined yet, the ability to experience, to connect, to find meaning in the universe, that's what's important.
It's like that's the whole point, you know? To find that meaning, to make those connections, to really live.
Maybe that's the whole point of the simulation. Who knows? But on that note, we'll leave you to ponder the mysteries of existence. Thanks for joining us on this deep dive into the computational theory of perceptions and the mind-blowing possibilities of the simulation hypothesis. We'll see you next time for another deep dive.